This video looks at the Unit 5 review. So if we start with the first set of problems, we're going to simplify using the imaginary numbers, or simplify using complex numbers. So the first one, we have negative 4i to the 14th. So we need to simplify I to the 14th. And now, as we talked about before, if we look at I to its different exponents, it's a pattern that actually repeats. So we treat I as just I, but if we had I squared, that's going to be negative 1. I to the third would be I times I squared, or negative I, which would lead to 4 being I squared squared, which would be 1. So it's a pattern that repeats, and then we could go back to I to the 5th would be I to the 6th would be negative 1, I to the 7th would be negative I to the 4th would be 1, and it keeps repeating. So we don't have to go all the way through that. We can just think of I to the 14th as a product or a multiple of 4. So we could think of it as 4 times 3, and then an I of what's left. Well, 4 times 3 is 12, that leaves 2 left over. So that's negative 4 times 1 times I squared. Now I squared we said was negative 1, so negative 4 times 1 times negative 1 would leave us with an answer of 4. Number 2 works the same way. I to the 27th. We want a multiple of 4 that's the closest without going over to 27. Well, if we look at 24, which is 6 times 4, that's one of them, and that would leave 3 left over, or I to the third. So it becomes 5 times 1, which is just I to the 4th to the 6th, times I to the third, which we said earlier, I to the third was negative I. So our answer becomes negative 5i. Number 3, we're combining like terms. 3 and 3 gives us 6. Negative 2i and 5i give us positive 3i. So it's 6 plus 3i. Number 4, more of the same. Maybe we can distribute that negative to start with. So it becomes 2 minus I minus 3 minus 4i plus 5 minus 2i. Then we can group them together. I have a negative I, a negative 4i, and a negative 2i, which combine to be negative 7i. And then 2, negative 3, and 5, which will combine to be 4, so our answer is 4 minus 7i. Number 5, we're looking at multiplying, so I'm going to distribute the 2i, so I get 10i squared plus 14i, and we're not going to leave it as that because we can simplify, because we said that I squared was negative 1, so that's going to be 10 times negative 1 plus 14i, which gives us an answer of negative 10 plus 14i. Number 6, we distribute again. We get negative 12i plus 15i squared. Now 15i squared is going to become 15 times negative 1, which is negative 15. We can put that out in front. Negative 15 minus 12i. Now we go to number 7. We're multiplying, and for this we're going to treat it like we're multiplying binomials. We could use FOIL. Let me use the box method here, just to kind of keep things organized as we start going through this. So we'll do 3 plus 6i, 2 minus 5i. We get 6, 12i, negative 15i, and negative 30i squared. So 6, and then I have negative 15i and 12i becomes negative 3i minus 30i squared, but we said I squared is negative 1. So this actually becomes plus 30. So we can combine that with the 6 and we get 36 minus 3i. Number 8, we should treat this as a multiplication as well. You're not just going to write it as 16 plus 49i squared. It's almost like binomial multiplication, so it's better if we write it as 4 plus 7i, 4 plus 7i. And we could use FOIL for this one. I'm going to do the first term times both terms in the second. That's 16 plus 28i. And then the first term times both terms in the second. That's 28i plus 49i squared. I get 16 plus 56i plus 49i squared, but we know I squared is negative 1, so it becomes 16. We bring that over, minus 49 plus 56i, and by simplifying we get negative 33 plus 56i. We'll do the same thing for number 9. 2 minus I, 2 minus I. Multiply the first term by both terms in the second. I get 4 minus 2i. Then it's going to be negative 2i plus I squared. 4 minus 4i, well, I squared we know is going to be negative 1, so we can just bring that down. It becomes 3 minus 4i. Now we're looking at number 10 where we have division, and we can't, similar to like when we have a radical, we can't leave an imaginary number in the denominator. We have to rationalize. And to rationalize for an imaginary number, we're going to multiply both the top and the bottom by its conjugate. So if it's 3 plus I, we're going to multiply the top and the bottom by 3 minus I. And the goal here is to clear out the imaginary number on the denominator and leave us with just a real number. So by using distributive property on the top, I get 21 minus 7i. So that one's taken care of. So now we have to look at the bottom and see what we can get to. So we'll multiply the first term by both terms in the second, 9 minus 3i. Then the second term by both terms in the second gives me 3i minus I squared. Now that's going to become 9. Well, negative 3i plus 3i becomes 0. So 9 minus I squared. Well, I squared is just negative 1, so it's actually going to become 9 plus 1, or 10. So the 21 minus 7i is along for the ride. It comes to the end, 21 minus 7i. We can write it there, but we should usually write this as a complex number, or simply 21 over 10 minus 7i over 10. And we'll move these over to there. Number 11, we do the same thing. Multiply the top and the bottom by the conjugate. That's 4 plus I, and it's just changing the sign in front of the I is the conjugate. So we get for the top is going to be 12i plus 3i squared. And the bottom we get 16 plus 4i minus 4i minus I squared. Let's jump down below here. So 12i plus 3i squared at the top, that's actually going to become negative 3 plus 12i because I squared is negative 1. And on the bottom we have 16 minus I squared. I squared is negative 1, so it becomes 16 minus negative 1, or 17 as our denominator. So we can write it there, but we should usually write it as a complex number, negative 3 over 17 plus 12 over 17i. Okay, now number 12, top and the bottom multiplied by 3 minus I. For the top, we're going to get 12 minus 4i minus 3i plus I squared. For the bottom we get 9 minus 3i plus 3i minus I squared. Let's simplify the top first. I have 12, that's staying there. Negative 4i, negative 3i is going to be negative 7i. I have I squared, which is negative 1. So that's eventually going to become 11 minus 7i. So for the bottom, I have 9 plus 3i, negative 3i becomes 0, minus I squared, which is just minus negative 1, which becomes 10. So we write it as 11 over 10 minus 7 over 10 I. Okay, 13, we need to graph our points, and whenever we graph on a complex plane, instead of using xy like we typically use, we're going to have our real and our imaginary. So the x-axis is the real numbers, the imaginary numbers is the y-axis. So 2 minus 3i, we convert that to be the point 2, negative 3. So we go over 2, down 3. This is 2 minus 3i. So negative 4 plus 2i would follow that same thought and becomes negative 4, 2. So we'd go 4 to the left, 2 up, and that would be negative 4 plus 2i. Number 14, we need to determine what do we need to add to both sides to complete the square. Whenever we complete the square, we focus on that b value, or the coefficient to the x. So we're going to take half of that value and square it. And we're eventually going to add to both sides. It's going to lead us to be able to factor. So in that case, we get negative 6 squared, which becomes 36. And we'll see in a few problems starting on 17 where we'll actually complete the square using this idea, but at least that gets us started for 14. Number 15, we need to find the sum, so we're going to add like terms. If I have negative 5 and 11, that gives me 6. 8 and negative 17i gives me negative 9i, so it's 6 minus 9i. Number 16, I have 7 plus I, and looking to multiply by 7 minus I. So I get the first term times both terms in the second. That's 49 minus 7i plus 7i minus I squared. The middle two terms become 0. I'm left with 49 minus negative 1, and that becomes 50. On 17, we're looking to complete the square. So we're going to focus on this value in the middle of the quadratic, the 4, and that's the coefficient to the b. We're going to take half of that value and square it. When we take that value, we're going to add it to both sides. So before we do that, why don't we move over the 1. So half of 4 squared. Looks like 2 squared, so we're going to add 4 to both sides. So x squared plus 4x plus 4 equals negative 1 plus 4. Now, what's nice now is the factors on the left side, so it's going to be x plus 2 squared equals 3. We can take the square root of both sides. We get x plus 2 equals plus or minus the square root of 3. We subtract 2 from both sides, and it's negative 2 plus or minus the square root of 3. We're going to follow the same idea for 18. So we're going to move over the 10 to the other side. So it's x squared minus 20x equals negative 10. And what I'm going to add to both sides is half of 20 squared. So that's negative 10 squared, or 100. So it becomes x squared minus 20x plus 100 equals negative 10 plus 100. This factors to be x minus 10 squared equals 90. I can then take the square root of both sides, and I get x minus 10 equals plus or minus the square root of 90. The square root of 90, though, is 9 times 10, so we can take a 3 out. So let's actually call that 3 root 10. Now I'm going to add 10 to both sides, and I get x equals 10 plus or minus 3 times the square root of 10. Last one, 19. We get x squared plus 2x equals negative 5. I'm going to take half of 2 and square it, so that just actually becomes 1. So x squared plus 2x plus 1 equals negative 5 plus 1. We get x plus 1 squared equals negative 4. We take the square root of both sides. We get plus or minus the square root of negative 4, which is actually 2i. So it's x plus 1 equals plus or minus 2i. It's an imaginary solution. And then we subtract 1 from both sides, and we get our solution of negative 1 plus or minus 2i. Now for 20, 21, and 22, we're going to use quadratic formula. So this is where we have our a value is the coefficient on the x squared, b is the coefficient on the x, and c is the constant. So quadratic formula is negative b plus or minus, we'll write that up here, negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. So we plug them in, we simplify, we'll find our solutions. And we'll do this when we can't factor. So if we try to factor x squared plus 5x plus 3, it doesn't factor down using our other methods, so we could use quadratic formula. So negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 3. All of that's over 2a. We get negative 5 plus or minus 25 minus 12 over 2. So I should put a 1 there instead of a. So we get negative 5 plus or minus the square root of 13 over 2. Can't simplify that anymore, so that will be our solution for our equation in number 20. 21, before we solve with quadratic, we have to get everything on the same side, so that's 3x squared minus 7x minus 12 equals 0. So now our quadratic formula will be a negative 7 plus or minus negative 7 squared minus 4 times 3 times negative 12. And that's over 2 times 3. This becomes 7 plus or minus the square root of 49. Now we have minus, but we have a negative in there, so that's going to become a positive. 4 times 3 is 12, times 12 is 144. That's all over 6. Now if we combine 49 and 144, we get 193. And thus we get the answer x equals 7 plus or minus the square root of 193 over 6. If we could simplify that radical anymore, we would, but that's the best we can do. Okay, 22, get everything to the same side. 2x squared minus 3x minus 10 equals 0. So our quadratic formula becomes negative times negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 10 over 2 times 2. So we get 3 plus or minus the square root of 9 plus, let's see, 4 times 2 gives us 8, times 10 is 80. And that's over 4. So our answer becomes x equals 3 plus or minus the square root of 89 over 4. So this last set of problems we have, we're going to solve for x. So if we can factor, if we can find other methods, we're going to do that. But if that doesn't work, we may have to complete the square or use quadratic formula. But we may have to use different methods and take different approaches to get there. So for 23, we can see if we have any common factors. We could actually take a 3 out of both of those, and we get 3x squared minus 12 equals 0. But if we stop there, we realize, well, maybe instead of a 3, we should have taken out a 9. So let's take out a 9 from there, and we get x squared minus 4 equals 0. And x squared minus 4 becomes x minus 2, x plus 2. So our two solutions we get is we get x minus 2 equals 0, gives us a positive 2, and x plus 2 equals 0 gives us a negative 2. So our two solutions are 2 and negative 2. Number 24, we have an x squared equals a negative 49. We're going to take the square root of both sides, which gives us plus or minus the square root of negative 49. Now if it was a positive 49, we would just say 7. But since it's a negative and we have an imaginary number, it's going to be plus or minus 7i. 25, we're going to move everything to the same side of the equation. We get 3x squared plus 40 minus 4 equals 0. That becomes 3x squared plus 36 equals 0. We can factor out a 3. So we get x squared plus 12. Then we put x squared plus 12 equal to 0, and that becomes x squared equals negative 12. Square root of that, we get x plus or minus the square root of negative 12. It's going to be an imaginary number. The square root of 12 simplifies to be 2 root 3. So we're going to write plus or minus 2 root 3. Now for 26. We could look at factoring first. I have 8 as my product. I needed to add up to 1. My factors of 8, well, it's probably not going to work there. We could use completing the square. We could use quadratic formula. Let's use quadratic formula for here. So we would take negative 1 plus or minus the square root of 1 squared minus 4 times 4 times 2 over 2 times 4. This becomes negative 1 plus or minus. We get 1 minus 4 times 4 is 16 times 2 is 32 over 8. Now, 32, 1 minus 32 is going to become negative 31, which is going to be an imaginary number. So our solution is going to be plus or minus I times the square root of 31 over 8. Okay, now we go to 27. We're looking for factors that add to negative 24, or multiply to negative 24 that add to negative 5. Negative 24, I have 8 times 3, so I could maybe go negative 8, positive 3. And we're just going to treat that x to the fourth x squared kind of as an x squared regular quadratic and see where that takes us. So we're going to say x to the fourth minus 8x squared plus 3x squared minus 24 equals 0. The factor by grouping, my first two terms I can take out an x squared, leaves me with x squared minus 8. Second two terms I can take out a 3, that leaves me with an x squared minus 8. They both have x squared minus 8 in common. Take that out, I'm left with x squared plus 3. I can continue to the factor, the x squared minus 8, that's going to be x minus the square root of 8, x plus the square root of 8, and of course we have the x squared plus 3. But we can actually simplify the square root of 8. The square root of 8 is 2 root 2, so let's clean that up. That's going to be 2 root 2. And you know, since we are simplifying here, we could simplify that x squared plus 3, because what if we set that equal to 0? We would get that x squared equals negative 3, so x equals plus or minus the square root of 3i. And since we have imaginary numbers, we can actually get the solution. So that will be one of our solutions, x equals plus or minus 3i. The other one will be plus or minus 2 root 2, like we got from the 8. All right, now on to 28. I'm going to move everything to the same side. I think it's time to change colors. We have 2x squared minus 7x minus 10 equals 0. We're looking for factors of negative 20 that add to negative 7. Don't think we're going to find any, so why don't we just go with quadratic formula. So that's x equals a negative 7 plus or minus the square root of negative 7 squared minus 4 times 2 times negative 10 over 2 times 2. We get 7 plus or minus 49 plus 80 over 4, which comes out to be 7 plus or minus the square root of 129 over 4. Now on to 29. I could divide both sides by 3. I get x squared equals 4. I take the square root of both sides, plus or minus the square root of 4. And it turns out to be x equals plus or minus 2. Now for number 30, last one here. Why don't we get our exponent, that x minus 4 squared by itself. So to do that, I'm going to subtract 1 from each side and say 6 times x minus 4 squared equals 36. I'm going to divide both sides by 6, and I get x minus 4 squared equals 6. So now I can take the square root of both sides, and I get x minus 4 equals plus or minus the square root of 6. And by adding 4 to both sides, it's 4 plus or minus the square root of 6 is my solution.